Hi everyone. Today I want to talk about sine and cosine graphs. This is going to be a wallop of a video, so buckle in tight. Also, so you know that I'm not completely heartless, I have a treat here in my hand. Titan, come here. Want a treat? Let's see if he gets up. Come here, buddy. Want a treat? It's right here. Come here. It's the wrong hand. Come here. It's right here. Look, it's right here. Come here. It's right here. That wasn't good, buddy. Here, let's try another one. I always come prepared. Get down now. Get down. You're welcome. Let's get right into it. Remember the unit circle? How could you forget? That should have popped up before. Okay, so we remember that sine values are y and cosine values are x. And each value of x and y are determined by the radian measurement or degree measurement. Hey, get down. There's no more for you. Get out. Which means that there is a dedicated relationship between radian measurement or degree measurement and the sine or cosine value. Now, this is going to be super helpful for us in graphing these things. Now, what if I took the unit circle and like cut or snipped right at the 0 degree mark, right before it gets back around to one full revolution of 360 degrees? What would it look like if I overlaid it on the coordinate plane? Well, again, here's our circle. So I'd be snipping like right there. There we go. At the point right before it gets back. So I'd unravel pretty much everything into a straight line. It won't go exactly straight because that's not how sine and cosine graphs work. So here, that dot right there of 1, 0 is the point of 0, 0, 0, 0 on the sine graph. So behold the graph of sine x. F of x, obviously. You could just say y, but that's elementary stuff. So what we have here is this dot and that dot are exactly the same point. If I were to unravel this unit circle, it would go along the coordinate plane in this fashion. Now, it might be a little bit difficult to see, but every major point or every point that we know of sine on the unit circle is on this graph. So for example, you can see the height here, or this kind of mountaintop, is actually the point of pi over 2, 1. And why is that? Well, we know that at a 90 degree angle, pi over 2, the sine value is 1. So 1 is right here. Just like its opposite or inverse part where we have pi over 2, 2 pi over 2, 3 pi over 2, we have a negative 1. Well, right here is the radian measurement of 3 pi over 2, which is negative 1. Now, hopefully you can see this point here at 2 pi. When we get back all the way around from one full revolution, this cycle repeats itself and I'm back to 0. So from this white dot all the way to this dot here at 2 pi, that represents one cycle of the sine graph. Now, the sine graph is infinite. Its domain is negative infinity to positive infinity. It is continuous and there are no breaks. We'll see that in a minute. But I just wanted to give you a snippet, I guess a little bit more than one of its periods, which is a vocab word. So we'll move on. Oh, that was a lot scarier than I thought it was going to be. Here is kind of a little bit bigger of a picture of the sine graph. So what do we notice here? Well, we notice again that I was talking about sine goes, it's infinite, right? It's all real numbers. Negative infinity to positive infinity is its domain, and its domain continues on this sinusoidal pattern of wavelengths to whatever degree, right? So here we can see that there is one full period where it starts at 0 on its increase, and then it ends right before it gets to its increase part again at 2 pi. So this represents one full period or one full cycle of a unit circle. And then everyone else is another full revolution, right? So from 2 pi to 4 pi, one more revolution, it repeats itself. Then it repeats itself. And then if I were going in the clockwise direction, I would still go to one period each. You can also notice that it doesn't go higher than 1. Now, it's certainly hard to see on this graph, but its highest point or its lowest point is 1 or negative 1, which again is another vocabulary type thing we're going to use in a second. So we are jumping right into the vocab, and there's a lot. So hopefully you want to write this down, save this video. So we're working with sine first, and why? Well, because I put sine first in the title, so I don't want to go a little too crazy. It's like literally right along my eyes. It's very strange. Let's see, is there a good place I can go? Okay, here. All right, I guess this is good. Important vocabulary. First thing I want to talk about is the period. I had mentioned that before. That represents one full cycle of the function. I'm going to go over here because the camera's in the way. Now, it means that we're going to go one full cycle before it starts to repeat itself. And a period is a major vocab word and a major indicator of its characteristics. For the sine function, the period is bracket 0 to bracket 2 pi. You may also see something that's happening here on the coordinate plane. Normally on a coordinate plane, we plot points x, y. It's kind of the same idea here, but in terms of trigonometric functions and trigonometric values, we're going to plot points in terms of radian measurement and actually then that function. So for example, instead of x, y on the coordinate plane, this is going to be radian, sine. Yeah. Now, next, amplitude. Amplitude is the height of a function. It's not as easy as that though, because it's going to be the height from the center line or the radian line to its highest point. So you might be thinking to yourself, well, sine goes to -1, which is like right here, right? And its max value would be +1. Well, min and max are two completely different characteristics when we talk about amplitude. Amplitude is literally just height. It's always positive, so it's always the absolute value, and it's from the center line up or the center line down. It's 1 on sine graphs. The amplitude will always be 1 on a parent function of sine. Now remember, parent functions are the basis of where all other transformations occur from. Sine x is the bare bottom minimum of your parent function. Doesn't get any more basic than that. So when we talk about the basics, these vocab words are where we're really kind of honing in on. Obviously, it's going to get way harder. So all of these characteristics or these vocabulary words are going to change in terms of their answers. Phase shift is the next one. Phase shift is the horizontal transformation or the horizontal shift from the initial point. Now, sine graphs go through the origin. They go from 0, 0, and then they go from there. And that makes sense because at the 0 degree measurement on the unit circle, sine is 0, which is why it goes through the origin. Now, the phase shift here, again, we're talking about a parent function. The phase shift is 0. It didn't shift left or right. Now, again, we would be able to notice that from our transformation standpoint, which is coming up shortly. Next, midline. We don't usually use that word anymore, but you may come up on quizzes or tests depending on who your teacher is and where you are in the world, universe even. Vertical shift is what midline is. Basically, if we had a phase shift, which is the horizontal shift, midline would be our vertical shift up or down. And that's just an addition problem. And again, on our sine graph, that is a parent function, the midline shift or the vertical shift is 0. They didn't go up or down at all. Okay. Last one that we'll talk about for today is going to be the increment. This is also referenced as frequency, so be really careful about those two words. They are interchangeable with each other. Increment or frequency represents how many things happen within one period. Now remember from a couple of slides ago, the period of sine is 0 to 2 pi. Now, when I say how many things or how many sections there are from 0 to 2 pi, think back to the unit circle. There are 4 quadrants in the unit circle. Now on the parent function of sine, it's changing itself or it's changing its values 4 times. What's going to happen now is we take that increment and we will divide that number by what the period is. So because the period here is 2 pi, we're going to divide that by 4. 2 pi divided by 4 is pi over 2. So again, when we talk about the increment, it's the period divided by how many things are happening in that section. Well, because again, the unit circle was broken up into 4 quadrants, that number is going to be 4, which will simplify to 1 pi over 2 or just pi over 2. So the increment or the frequency of the sine graph, the parent, is going to be pi over 2. Now, to make that a little bit more fluid, I'm probably going to mess this up. See how there's a major change right there? It goes from positive territory to negative territory. Well, that's one difference. See here how it changes from, it goes to its peak where it's going to be going uphill and then stops and goes downhill. And then see here how it's going downhill, stops on a dime, and then goes back uphill. Well, all of those represent the increments that are happening. So we have 1, 2, 3, 4. There are 4 increments, which is the frequency of 4 for our parent function of sine. Now that's going to change again significantly as we move forward with transformations of these things. Okay? Now, finally, there is a formula. It is like the formula for recognizing what's happening with our trigonometric functions. And that formula is a times sine in parentheses b in another parentheses, which also can be represented as brackets, x plus c, and then end your bracket and your parenthesis plus d. So what do all these things mean? Well, a is going to represent the amplitude or the height. Think vertical stretch when we talk about transformations. B is going to be the period, which is 1 full cycle. Now that's going to be represented like I did before of that 2 pi over whatever the period is. In this particular case, that period was 4. But our B value is going to be the actual number value that ends up being how many increments or frequency of that portion. So for example, this was just 2 pi over 2 pi because sine x doesn't have a b in front of the x part, right? So when you have a number in front of x, that's the b value. C is going to represent the phase shift, the horizontal shift left or right. And that also makes sense if we think back to transformations of all types of functions. Whatever the value was next to x inside parentheses represented a horizontal shift left or right. And then at the very end, we have plus d, which is the midline or the vertical shift. And again, if we think back to transformations of all kinds of functions, quadratic, exponential, logarithmic, whatever was at the very end of the function, plus or minus, was how it shifted up or down, and that's obviously addition or subtraction. This formula is super, super important, and we're definitely going to be playing a lot with this as we move forward. Now, all of that was the wonderful cosine function. But let's take a look at cosine. Cosine is exactly the same format. Now, the biggest difference is, again, if I cut the unit circle right before it got to its 360-degree 1 revolution, this would be what the cosine function looks like. What you notice may be kind of small, but it's actually really important. Cosine is x values. Well, at the 0-degree mark, meaning 0 on the coordinate plane, cosine's 1. Well, these 2 white points represent the same exact value, just on different representations. Unit circle representation versus the coordinate plane representation. So 1 is where cosine starts. And cosine obviously is going to have the similar format to sine because it lives on the coordinate plane and has the same values, technically speaking, as sine does. So again, here's cosine kind of extrapolated out a little bit. And what do we notice here? Well, we notice that it looks exactly the same as sine, just shifted over a little bit. But cosine goes through 1. So it's going to be our 0 radians and 1 unit. And it's just going to go from that wavelength on through there. Again, its domain is negative infinity to positive infinity. It's infinite. It's continuous. It never stops. Right? Now, let's use that same vocabulary for the cosine function. The period is the same exact thing. It represents what's happening before it starts to repeat itself. Now, here is where it starts. And then at 2 pi is where the pattern repeats. So again, just like sine, cosine's period is 0 to 2 pi. Amplitude is again that absolute value positive number of its height starting from the midline center. So from the radian measurement line, again, we have a 1 value for the amplitude, which is the height. Phase shift, there was no phase shift on the parent cosine function. It didn't shift left or right. And then we have our midline vertical shift. Again, the parent function of cosine is almost exactly like in terms of behavior of the sine function, where there is no vertical or horizontal shift. And again, we have the increment of cosine is pi over 2, because again, there are 4 things that are happening on this graph. Now, the formula is exactly the same, and we will go from there. Okay, let's finish up. Things to remember about this video. Number 1. Titan will get a treat if you put it on the top of this table. Oh, hello, buddy. Sorry, you've had a lot today. So have I. Not dog treats, human treats. Like candy. Moving on. Number 1, graphs of... Get out of here, pal. Graphs of trigonometric functions are represented in the ordered pair of radian, comma, function. So for example, on the sine function or the sine parent, we have radian measure, which is our typical x value, and then the sine value at that x value represents the ordered pair. Number 2, remember your vocabulary. It's super important. We can think of it in terms of transformations, which is how we're going to apply these things moving forward. And then number 3, if we identify each piece of the formula, we will be able to find out important characteristics in terms of graphing. So when we talk about these trigonometric functions, really 2 things pop up. Number 1, what are the characteristics of them? And then 2, what are the transformations that apply with those characteristic rules? So first step is, let's make sure we understand the rules, and then we can move forward to more difficult concepts. See you later.